Hey guys, and welcome to your next tutorial. In today's tutorial, what we're going to be doing is learning what a vertex buffer object is and how we can use it. And we're going to use a vertex buffer object to implement our sprite class so that we can draw two-dimensional sprites to the screen for our little players and tiles and all of those things. So first I want to start off by saying Daniel Collier commented in one of my previous videos that for some people, you may be getting weird crashes with OpenGL with glue, and one way you might be able to fix that is to go above glue init and type glue experimental equals true. Now you shouldn't need this for the most part. Like most people should not need this, but if you're getting weird crashes, try this and see if it fixes your issue. Okay, so first of all, let's go down here. I want to mention that here I told you that we could go like 0 to 500. This is actually going way off the screen. When I run it, you're going to see this triangle goes really high, and it's actually going really, really far because I'm setting the coordinates as 0, 500, 500, 500, but actually the way the coordinate space works with OpenGL is it uses what's called normalized device coordinates, and I've got a little picture of it right here. As you can see, what happens is the left side is -1 in the x-axis, the right side is 1 in the x-axis, and the same for y. The top is 1 in the y-axis, and the bottom is -1 in the y-axis. So if you actually wanted to do a proper triangle, let's say we wanted to make it in the bottom left-hand corner, we could do like -1, -1, and then for x we could do 0, -1, y, and then we can do 0, 0 for the third vertex. And now when we run it, we should get a proper triangle in the bottom left. But that's not really what this tutorial is about. We're actually going to delete all this and make something much better. We're going to make our little sprite class. So no longer will we be using immediate mode. So we can grab all this crap right here and delete it. So let's go ahead and make our sprite class. So if you don't know what a sprite is basically just like a 2D image or a two-dimensional, usually they're squares. So we could type sprite games or whatever. I'm just picking two random words. Here we go. So as you can see, if you just Google that, you can see all of the different little two-dimensional characters that make up the games. These are called sprites. So we're going to make something like that. We're not going to have textures just yet, but we will be able to do that later. So let's go ahead and go to graphics tutorials, go to add class, and we're going to make a new class and we're going to call it sprite. So let's click add, and we're going to say class name is sprite, and we're going to finish that. And this, for us, sprites will always be two-dimensional. We will move on to three-dimensional rendering later, and we'll call it something else. So here is our sprite class. We have a constructor and a destructor. So we need to give it a few methods. So we're going to need a method to render the sprite, to draw it. So we're going to say void draw. So that will draw the sprite. And we're also going to need a method to like set its position, to initialize it. So let's make an initialize function. We're going to say void init, and we could do this with the constructor, but I'm choosing to do it with the init function. And what are we going to need to give our sprite? Well, we're going to need to give it a position, right? And we're going to also need to give it like dimensions. We're going to assume that our sprite is a square, that we're eventually going to color and texture and all of that. So let's go ahead and just pretend it's a square. We're going to say, we'll give it the coordinates for the bottom left-hand corner. And we could do two different coordinate spaces here. We could use normalized device coordinates, which is the, here we go. Did I lose that image? Here we go. We could use normalized device coordinates, or we could use screen coordinates, and we can convert them to normalized device coordinates. So I think we should use screen coordinates. That makes it a little bit easier to work with. So we're going to say int x, int y, int width, int height, like that. And now we're going to need to store those variables. So let's make a private field, and let me zoom in so you can actually see what I'm doing here. Private. So in our private section, we're going to add some private variables. We're going to have int underscore x, int underscore y, int underscore width, int underscore width, and int underscore height. So here's our private variables. Here's our init function and our draw function. Let's go ahead and copy those into sprite.cpp. Right now we're not using our constructor or our destructor. There we go, and we're going to say sprite : init and sprite : draw. There we go. And our destructor, what we're going to do is use that to do just a little bit of cleanup, so we'll add that in later. All right, so these are right now probably the only two functions we need. We are going to want to be able to move our sprite, but we can add that in later. For now, we're just going to go really basic. So first thing we want to do in our init function is set our private variables. So x equals x, y equals y, width equals width and height equals height. Now, here's where we actually want to do our rendering. Now, our sprites are going to be really basic right now. We're just going to be drawing something to the screen. Now, we could use immediate mode for this, but that is actually really slow, and we don't want to do that. Let me pull up Paint here, and I'm just going to draw you a little diagram. Here is our CPU, and here is our GPU. Okay, so the GPU stands for Graphic Processing Unit, so GPU, and here's the CPU. So what happens whenever you use immediate mode is you have to send over all the vertices one at a time to the graphics card, and then the graphics card will draw them to the screen. And if you're using the fixed function pipeline, it just ends up being really, really slow. Instead of sending each vertex one at a time, what we can do is allocate what's called a vertex buffer object. So I'm going to draw it as a little square on the CPU. So here's our vertex buffer object. And it's called a vertex buffer object because it's a buffer. It's like an array, or it is an array of vertices. So what we're going to do is fill this array with all the vertices for our triangles, and then we're going to do a buffer upload. And what that does is it takes this vertex buffer object and it moves it over to the GPU. So it's going to move over here, and then we're going to have this little square on the GPU, provided that we have enough video RAM, which we will have plenty of video RAM. So now that the vertex buffer object is on the GPU, unless we change the vertex buffer object, we never have to copy anything over again. We don't have to send vertices to the GPU every frame like we did with immediate mode. Instead, all we have to do is tell the GPU to draw it. That's literally all we have to do. We save a bunch of bandwidth, it runs way faster, and we can batch a lot of different objects into one vertex buffer object. So let's go ahead and create our vertex buffer object. Now what we're going to want to do is store the vertex buffer object in our sprite. And the way this works with OpenGL is you create what's called a vertex buffer object ID. And this ID number is, you could kind of think of it like a pointer to the vertex buffer object. It's pretty much managed by OpenGL. You just tell OpenGL which vertex buffer object you want to bind and draw using that number, and it will handle everything for you. So first thing we want to do is let's go to our sprite and include GL glue. That will make sure we have all our OpenGL stuff because we do need that. And then when we go down here, the type that a vertex buffer object ID is an unsigned int, like this. And we're going to say, we'll call it VBO ID. Now, instead of calling it an unsigned int, what we should do is type GLUint, like this. And this is the exact same thing as an unsigned int, except it's guaranteed to be 32 bits. An unsigned int is not guaranteed to be 32 bits. It could be 8 bytes. It could be 64 bits. However, OpenGL provides us with these special types. GLUint stands for GL unsigned int. So this is going to be an unsigned int that is guaranteed to be 32 bits, and this is what the type that OpenGL expects you to use for vertex buffer objects. So we're going to copy that to our initialize, or our constructor here, and we want to set that to a 0. You always want to start off your vertex buffer objects to 0. It's like setting things to null. Now in init, here's where we're actually going to create our vertex buffer. So the first thing we do is we generate the buffer. So what we want to do is only generate this buffer if it hasn't already been generated. And how do we know if it hasn't been generated? If it's equal to 0. So what we're going to do is say if VBO ID is equal to 0. And if that's true, then we know that it hasn't been generated yet. Now what we're going to do is we're going to tell OpenGL, hey, take this vertex buffer ID and allocate it to a buffer. What it's going to do is it's going to create us what's called a vertex buffer object, and it's going to assign it to this ID here. And the way we do that is we type GL gen buffers. This stands for generate buffers. And first we tell it how many buffers we want. We just want one buffer. And then we're going to pass in the VBO ID. You can notice if you look closely, it says GLUint star buffers. We're passing this VBO ID in as a pointer, and it's basically being passed by reference. So what's going to happen is when we pass in VBO ID, it's going to generate a vertex buffer and then change VBO ID to equal the ID of that buffer. And whenever you generate new vertex buffers, they're always going to be unique numbers. You're never going to have two vertex buffer objects that have the same number ID. So that will generate our buffer. Now what we need to do is actually upload the data to that buffer. but we don't have our vertex definitions. We could hard code them, but instead what I'm going to do is use these x, y, width, and height variables to actually construct our vertex definitions. So since we're making this a square and we're going to assume it's a square, then that means we're going to need 6 vertices because we need 1, 2, I don't have a mouse pad, so my accuracy is a little messed up. That's 3 vertices for one triangle, like that. And then we need 3 vertices for another triangle. Even though 2 of these vertices are going to overlap, that's okay. So 1, 2, 3, like that. Or however you want to wind them. There we go. And that will create our beautiful, beautiful square on the screen. A square is called a quad. A quad is always 2 triangles. So what we need to do is create space for those vertices. And what we're going to do is make an array of floats, because each coordinate, x, y, and z, are a float. So we're going to say float, and we can say vertex data, and it's going to be an array of floats. And how many floats do we need? Well, we have 6 vertices times 2. We're not doing x, y, z, we're just doing x and y. So it's going to be 6 times 2 floats for us to use for x and y for 6 vertices. So I'm just going to type 12 here. And we're going to set that. So now what we need to do is actually set these vertices. So we can hard code this, we can use for loops, we can do whatever we want. Since it's really simple, I'm just going to hard code it. We're going to say vertex data 0. Let's assume this is the top right corner here. Vertex data 0, this is the x coordinate. That's going to be equal to x plus width. Vertex data 1, this is the y, is equal to y plus width. And let me actually have these side by side so it's easier for you to tell what I'm doing. All right, you could be clever and probably do a for loop with this, but I'm not being clever enough right now, so I'm just going to hard code it. That's okay. Here we go. We'll move this over here. There we go. So this top right corner is going to be the first vertex. Next, we're going to do, and I'll circle these one at a time. So we've done that one. Next, we're going to do this one. So we're going to say vertex data 2, this is the x coordinate, equals, and that's just x. Vertex data 3 equals, and that's going to be y plus height, and this should be height, not width. All right, so that's 0, 1, 2, 3. Vertex data 4 equals, and that's going to be just x. Vertex data 5 equals y. There we go. So this is the first triangle. Now we need to do 3 more vertices, so 6 more floats for the other triangle. So let's put a comment here. First triangle, triangle, and then second triangle. So this triangle, I'm just going to copy this and change it so it's easy. Now the first triangle we'll say is this bottom left one right here. And that bottom left one is the same as the last one we just did, which is just xy. And let's change all these numbers. This should be 6, 7, 8, 9, 10, 11. Beautiful. 11. So now the next vertex is the bottom right, and that's going to be x plus width, and the height is going to be just y. And then finally, vertex data 10 and 11 is going to be this top right corner, which is the same as the very first vertex we did, which is x plus width and y plus height. So there we go. These are going to be the vertices not in the normalized device coordinate space like the image here, but in our screen coordinate space. And what we're going to probably do is just whenever we call init on our sprite, we will convert our screen space coordinates to normalized device coordinates. We can do a little math to do that. It's very simple. So that creates our vertex data. That's good. Now let's go ahead and upload the data. So to do that, what we do is make a function call called GL Buffer Data. And then in parentheses here, first we say the target. And actually, in order to do that, we have to bind the buffer. So we generated the buffer here, but we didn't bind it. So first we bind it with GL bind buffer. And this basically tells OpenGL we now want this buffer to be active. And first we need to tell it what type of buffer we want it to be. And the type of buffer we want to use right now is called the GL array buffer. That's just your basic Vertex buffer. Then comma, and we tell it which buffer. And it looks like my stuff is crashing. I hope it's not crashing. Okay, we're good. GL array buffer, comma, and we tell it which buffer, which is going to be just VBO ID. Now we do GL buffer data, and we tell it which bound buffer we want to use, and we're using the GL array buffer that we just bound, comma, and then we say the size. So this is the amount of data. And all we have to do is, since this is just a static array, right, we know the size of it, we can just say size of, and then vertex data. So size of vertex data, that's how many bytes this data is going to be. And now we tell it what is the data. And to do that, we need to pass a pointer to the beginning of the data. And that pointer, remember, pointers can be used as arrays, and arrays can be used as pointers. So all we have to do is take vertex data right here, which is an array, and plop it right there. And it's going to know that that's a pointer. Then we hit comma, and we say the usage. This is basically just hinting to OpenGL, how are we going to use this? Are we going to draw it just once? Are we going to draw it many times? We're probably going to draw it just once every now and then. So for now, we can just say GL static draw. It's not super terribly important right now. So that's it. That will bind the buffer, and then it will upload the buffer data. And for good measure, what we should do is unbind the buffer. You don't have to do this, but it kind of makes things a little safer. So we can say GL bind buffer, GL array buffer, 0, and that will unbind the buffer. Anytime you bind the 0 ID, that's the same as saying I don't want to bind anything, because the way these Vertex Buffer IDs work is they're always going to be a positive number if you've bound a vertex. It will never, this GL gen buffers will never set VBO ID to 0, because 0 indicates no buffer. So there we go. That is going to initialize our sprite. It's going to bind our buffer and everything. And one thing we should do now for safety is whenever our sprite is destroyed, because remember the destructor runs when the sprite is destroyed, we should free this buffer. And what that's going to do is it's going to tell the graphics card, hey, we don't need you to hold on to this vertex buffer anymore. You can go ahead and get rid of it and use it for something else. You can free that RAM or that VRAM. So what we can do is make an if statement. If VBO ID is not equal to 0, because we don't want to delete the buffer if it doesn't exist, then we'll call GL delete buffers. We're going to delete one buffer, and then we just need a pointer to the buffer. This is pretty much the exact opposite of GL gen buffers. Really simple. So there we go. That will clean up after ourselves. That's really nice and good. And we have a init, we have the constructor and destructor. Now what we need to do is draw the sprite. So drawing is actually pretty simple. What we need to do first is bind the buffer. So we're going to say GL bind buffer, and we're going to bind it as the array buffer. So GL array buffer VBO ID. That tells OpenGL this is the current buffer that is active. We can only have one GL array buffer active at one time. So we'll bind it there, and let's also remember to unbind it at the end. So I'll put this down here. Now, what we need to do is tell OpenGL what kind of attributes we are giving it. And right now we are only giving it position. We're not giving it color or anything like that. We're just going to give it the basic position. So we're going to say GL enable vertex attrib array, I believe. And we're going to tell it which vertex attrib array we want. And we're just going to enable 0. So we're sending one vertex attribute array, which is our array of just positions. We don't have lighting information, we don't have color, all we have is position. So we say we only want one vertex attribute array. We're just going to use 0, which is the 0th index. So you can think of this as an array, and we're only using the very first element of the array. And then what we need to do is remember to disable that after we draw. So we're going to say GL disable vertex attrib array 0. Now in here is where we do the drawing, and we also need to tell OpenGL where our vertex data is in the vertex buffer ID. And the way we do that is we say GL vertex attrib pointer like this. And what this is doing is it's basically telling OpenGL we're pointing OpenGL to the start of our data. So we gave it a VBO, but we may not always want to draw the entire VBO. We may only want to draw a part of it, or maybe draw it in sections, or draw every other vertex or something like that. So this gives us a little extra functionality here, but we're just going to use it to draw the entire vertex buffer object. So first we say which vertex attribute array this is, and we enabled the very first array, the 0th index, so we're just going to type 0 here, same thing. Then we type a comma and we say glint size. So this size variable is basically the size of one vertex. And in this case, it's going to be 3. It's not the size in bytes, it's the number of elements. So we're going to say, or sorry, it's 2, because we're doing just x and y. I'm trying to think in 2D right now. So 2 stands for an x coordinate and a y coordinate. Then we type comma, and it's going to say, now we want the type. So what is the type of variable that we are using for our positions? And in this case, we are using floats, right? Because these vertex data this vertex data array is made of floats. So we're just going to say gl_float, and that will tell it that we're using floats. So now it's going to be able to figure out that since we have floats and we have 2 floats at a time, then it's going to go 8 bytes at a time, right? So we type comma, and it's now asking us for normalized, GL Boolean normalized. You don't need to know what that does right now. We just want to know that we don't want to normalize it. So we're going to say GL false. I will teach you more about that later, comma. Now it's asking for the stride. Also put that to a 0. We'll learn more about that. And then finally, it's asking for a pointer. And right now we don't care about this because we're not using what's called interleaved vertex data. We will learn how to do that. So for now, you can also just say 0 right there. And then at the end, we can put a semicolon. So this sets up our vertex attribute pointer. It tells OpenGL this is where our data is, this is how you should draw it, or this is where you should start when you decide to draw it. And finally, what we need to do is actually draw the data, and then we are done. All we have to do is type gl draw arrays, and this draws our array of vertices. Very simple. So first we need to tell it what mode. Now, like whenever we did GL begin in tutorial 4 where we said GL triangles, we're going to do the same thing. We're going to say GL triangles. There are other things we can do. We can also say GL points if we wanted to draw points. That's not how you spell points. We could also do GL quads. This will draw squares. And I know you're thinking, well, if we want to draw squares, why didn't we just do GL quads? Why are we doing triangles? Well, a lot of computers actually don't support GL quads. What they do is whenever you say GL quads, they just convert it to 2 triangles anyways. Your graphics card works in triangles. It doesn't work with quads. Everything is triangles. So you might as well just say GL triangles. It's not going to probably be slower than GL quads, but you can be guaranteed that GL quads will probably never be faster. GL triangles, like that. When in doubt, go with triangles. Now, GL int first, this is saying what is the very first element, and we're just going to say 0. We're just starting at 0. And now we're going to say how many of these elements are we drawing. And we are drawing 6 vertices, right? 6 vertices, and each vertex is 2 floats, which we told OpenGL right here. So it can figure out all of this stuff just by the things we've been telling it so far. So we're going to say 6 vertices. And that is it. This should be able to draw our sprite. So now let's actually use this in our game. Let's go to main-game.cpp. Let's include sprite at the top. Include, and we're going to say sprite.h. Now we need to create ourselves a sprite. Actually, let's go ahead and put this in the header file so we can make a sprite in the header file. Include sprite. And down here, let's make a sprite. We're going to just say sprite. We'll just say this will be a little test sprite. We're going to get rid of this later. And first thing we want to do, and let me zoom in case you can't actually see what I did. Made a little sprite down here, private variable. Let's come over to, let's see, run here. And right before we do the game loop, let's just hard code this in here. Let's just initialize it. We're going to say sprite.init, and this is going to initialize our sprite. Now normally we're not going to want to just hard code this in here into the run loop, but we will fix this later. This is just for practice. So let's say the x coordinate, remember this is normalized device coordinates. Let's just go ahead and say the x coordinate is -1 and the y coordinate is -1. So this is going to be at the bottom left hand corner. And then for the width, let's go ahead and say the width is 1 and the height is 1. So this is going to basically just spread it from the bottom left hand corner to the middle. So if we go into Paint here, And if I draw a box like this, we're going to end up with the quad looking like this in that little corner right there. And actually, we probably should not be sending in position and width as ints. Let's convert these to floats because we're losing a lot of precision that way. These should definitely be floats. This is an easy fix. Go to sprite.cpp and do that. Go to sprite.h and do that. Just convert these to floats and then convert these to floats. That's correct. And now we are correctly signing floats to floats here. We were not doing it correct the other way. So that is going to initialize our sprite, and we can type 1.0f here to be completely correct since these are floats. Now all we want to do is in our draw game loop is we're going to call sprite.draw. So sprite.draw like that. So let's run it and hope to God that we get something on the screen. There we go. Holy crap, first try, we did it. That never happens. So as you can see, we have our little quad here at the bottom left-hand corner. Now, if you look, you'll notice it's not a perfect square, even though we specified the coordinates to be a perfect square, because remember, we are using normalized device coordinates right now. We're not using our screen coordinates, so it's not taking into account our aspect ratio. The aspect ratio is the width divided by the height of your screen, and that's going to kind of cause a little distortion if you're not taking that into account, but we will take that into account. We're going to learn a lot more cool stuff. We're going to learn how to move our sprites around. We're going to learn how to color our sprites, and most importantly, we're going to learn how to use shaders to make really cool effects and all sorts of amazing things. So stay tuned for the next video. I hope this was fun. See you later, guys.